Hello, we're going to look at trigonometry for right-angled triangles now. It's a big topic, it's a tricky topic, so we'll see if we can crack it. Okay, what is trigonometry? When do we use it? So it's used in right-angled triangles, and it's used when we have an angle or we're looking for an angle. So if it's just lengths, you've hopefully seen this before, Pythagoras. I would encourage you, if you haven't seen Pythagoras before, to do that first. This is a Pythagoras example, this first one on the left here, because it's just got lengths. It's got lengths, two lengths, and we're finding a third length. Trigonometry is used when we have an angle involved. So trigonometry is in right angle triangles whenever there's an angle involved. So you can see in this one we have a useful angle, and so we're going to use trigonometry. SOH CAH TOA, we'll come to what that means in a minute. So right angle triangles when there's angles involved, that's when we use trigonometry for finding missing lengths or angles. Okay, here are three examples of triangles, and what I'd like you to do is pause this now and decide which of these three triangles requires trigonometry. Which ones of these would we use trigonometry for? So it's right angle triangles with angles. Pause. Continue. And the answers are this first one here, because it's got an angle involved. Not the second one, that's just length, so that's Pythagoras. And the last one, we're looking for an angle, so again that would be trigonometry. On we go. So once we know we're using trigonometry, the first thing we always do is we label up the triangle. So we get a triangle, and we label it with the hypotenuse, which is the longest side in a right angle triangle. So in this example here, the hypotenuse there is the long side. So remember, hypotenuse is always the longest side. And if you're not sure which one the longest side is, it's always opposite the right angle. So there we go, we label up H. Next thing we're going to label is the opposite side. And the opposite side is opposite the angle we're using. So this one here is the opposite side. So we label that O. So we've got hypotenuse, opposite, and the final side is the adjacent. And what adjacent means is next to. So next to our angle we have this side, and that is our adjacent side. So we label hypotenuse, the longest, opposite, opposite the angle, and the adjacent side. Okay, here are two examples for you to try. See if you can label them up with hypotenuse, opposite, and adjacent. Pause the video. Continue. And labeling this one, we have hypotenuse, the longest side here, opposite the angle over here, and adjacent here. Hypotenuse, opposite, adjacent. On the next one, we have the hypotenuse is the 18 meters. Opposite the angle is over here, and adjacent next to it is there. Hope you got that. So that's always the first thing we do. If you get that right, you're off to a very good start. Okay, the next bit is going to introduce this letter here called theta. It's going to introduce sin or sine, cos or cosine, tan or tangent, and SOH CAH TOA. So if you've never seen these before, could be confusing at first. So make sure you are paying full attention and get ready. So here we go. This letter here is just like any other letter, but it's a Greek letter, and it's theta. And in maths we often use that to represent an angle. That's all it is, it's a letter. So for example here we have an angle, we don't know it, we'll call it theta. Now we have this. Now this is sort of one of the ratios that is sort of the basis of what trigonometry is. And this is nothing to be scared of, although the language looks kind of confusing. All it means, this ratio here, all it means is that if we know an angle in a right angle triangle, then we can also know that there's a relationship between the opposite side and the hypotenuse. So sine, or sin, tells us, when we know an angle, what's the relationship between the length of the opposite and the length of the hypotenuse. For example here, if we have a 30-degree angle, the relationship between the opposite side and the hypotenuse is that the hypotenuse is double the opposite. And if we enlarge that triangle, then it's still true that the opposite side times 2 gives us the hypotenuse. And we could enlarge it even further, and the relationship is still true. The hypotenuse is double there, with a 30-degree angle. And that works for all angles. There's always a relationship that we can find out for any angle. And that is the sine ratio, the opposite divided by the hypotenuse. Okay, there are 3 of these that we need to know. Sin, cos, and tan. And sin is the relationship between the opposite and the hypotenuse. Cos is the relationship between the adjacent and the hypotenuse. And tan is the relationship between the opposite and the adjacent. Sin, cos, tan. And we can remember these 3 ratios using the word SOHCAHTOA. SOHCAHTOA. So the first one, sin, is opposite over hypotenuse. Cos, C, is adjacent over hypotenuse, CAH. And tan, TOA. Tan is opposite over adjacent. That is something you do need to know. You need to learn that. SOH CAH TOA, to remember that sine is the relationship between opposite and hypotenuse. Cos, adjacent over hypotenuse, and tan, opposite over adjacent. Right. We can use those ratios to find missing lengths, or indeed angles, in right-angled triangles. What he said, SOHCAHTOA, remember it. Here's our first example. Let's put this into practice. So this is the first sort of proper trig question we're going to do. So our first step is going to be to label up that triangle. Like we were earlier, label hypotenuse, opposite, adjacent. And in this case, the hypotenuse is the 10 centimeters, the opposite is x, and the adjacent next to it is there. So we label it up, always the first step. Second step, we need to choose which of these ratios we're going to use. Is it sin, or cos, or tan? Well, the way we do that is we look at what lengths we've got, what lengths we're looking for, and what's irrelevant, what don't we need. So, I've got this 10 centimeters, that's useful, that is helpful. I've got this, x is what I'm looking for. What I'm looking for, again, that's also important. This adjacent side, I haven't got it, I'm not looking for it, useless. So, we are dealing with h and o, hypotenuse and opposite. I choose the one that I've got, the one I'm looking for. And in this case, O and H, let's have a look. O and H, that is the sine ratio. O and H. This one involves adjacent, this one involves adjacent, so no good, no good. Okay, so we've chosen sine. That's the ratio we're going to use. So we're going to take this, SOH, and we're going to substitute in the values that we know. So, I know that theta is the angle, so that's 28 degrees. I know that the opposite is x, that's what we're looking for, and the hypotenuse is 10 centimeters there. So we're going to substitute those into this formula. So let's do that now. So I'm just going to move my head up there. So we substitute in 28 for theta, we substitute in x for the opposite, up here, and we substitute in 10 for the hypotenuse, down here. And then we just take one step to try and get x on its own to solve it, and that is to multiply by 10. Times this side by 10, times this side by 10. And we get to 10 multiplied by sine 28 equals x. So that comes out as 4.69 to 3 significant figures. The way you can type that in your calculator, you can go 10 sine 28. You can do 10 multiplied by sine 28. You can do sine 28 multiplied by 10. But one thing to watch out for is make sure you do not do this. Make sure you close that bracket. I've seen this mistake a couple of times as a teacher. So just be careful that what you're doing makes sense. This answer is clearly rubbish. You can't have a length of negative 0.9 on a triangle. Okay, that's your first example. Wow. Here's your second example. Okay. Step 1, label HOA again. this is just another example. Labeling it up, hypotenuse, opposite, adjacent. Hopefully that makes sense. Now we're going to choose sin, cos or tan. Well, here I've got the adjacent, that's useful. I'm looking for the opposite, so we need the one that involves adjacent and opposite. This one, no. This one, no. Here it is, it's tan. I'm going to use tan theta equals opposite over adjacent. And again, we substitute in our values. So theta is 32, so tan theta 32 equals opposite. Opposite is B, that's what we're looking for. And the adjacent is 5 there. So I've substituted these numbers into the right place on this tan ratio. And when I type that, when I get this, I need to now multiply by 5. So there we go, there's my next step. Times by 5, and I get 5 tan 32 equals B. Type that in your calculator, and you should get 3.12. And there you go. Right, I just want to, you can take this or you can leave it. This is another way to approach these problems. Some people like it, some people really don't. I think it's quite a nice shortcut if you can remember how to set up these triangles. So if we look at this problem, this was how we solved it here. There's another way where you can use these triangles. You may have seen them with speed, distance, time, various other ones in physics. What you do is you cover up the thing you're looking for. So if we look at our problem here, we are looking for the opposite. So you still do the first 2 steps, label up your diagram, and then you put TOA into this triangle. So I'm going to cover up the O. I'm covering up the O, so I'm going to do tan theta times the adjacent. And when I do that, tan 32 times 5. You can see it's basically the same thing as this. Some people find this quicker, some people find it means they don't have to do quite so much manipulation. If you want to use it, up to you. Okay, moving on. Remember that word. Here we go. Example number 3. Right, there is the last 2 will multiply. This next example is a little bit trickier, but the steps are still the same. So we label it up. Hypotenuse, the longest side. Opposite the angle. Adjacent. Job done. Then we choose sin, cos or tan. Well, this is what we're looking for. This is 20. We've got it. It's useful. This one, we're not using it. We're not looking for it. So we want A and H. And A and H, let's have a look, is cos. That's the ratio we're going to use. So, substitute my values in. And when I substitute the values in, adjacent is 20. Hypotenuse is what we're looking for, that's n. My angle is 40. So I've got this. Now the problem is, I'm looking for n, and it's the denominator. It's on the bottom of a fraction. That means we've got to do a little bit more work. So the first thing I'm going to do is multiply both sides by n to get this n to stop being the denominator. And when we multiply by n, we get 20 on this side, and we get n times cos 40 here. I want n on its own, so I'm going to divide by the cos 40. And when I divide by cos 40, cancels this out here, and we get n equals 20 divided by cos 40, and that will give me my solution. So I pop that in my calculator, and I should get 26.1. Let's just see what that would look like on a calculator. You can either put in 20 divided by cos 40, or you can set it up as a fraction. Use the fraction button. Either way, same answer, no problem. Alright, so that's the sort of harder type of finding a length within trigonometry. I'm going to give you 4 questions now to have a little practice. Oh, just before that, let me just demonstrate how it would work with the triangle. In this example, we're saying that we are looking for the hypotenuse. So I cover up the hypotenuse, and it's adjacent divided by cos theta. So for this example, this is a little bit quicker. It's quite handy because I can just type in 20, the adjacent, divided by cos 40. Okay, so we have adjacent divided by cos theta. And you type in your calculator 20 divided by cos 40. There we go. Right, let's listen to this fellow again. Yeah, remember, SOHCAH TOA. Okay, here are 4 examples for you to try. Find the missing length in these 4 triangles. Remember, follow the steps, see how you go. So pause the video, answer these, and then we'll continue. Pause. Continue. Okay, here's the answers and how I got them. So check through those and make sure you're typing things in right on your calculator. Any corrections you need to make, go through them and do that. Alright, on we go. We've got one more thing to do now. So we found lengths with some dividing, some multiplying. There's one more thing that you might have to do, and that's to find an angle. Okay, so finding an angle using trigonometry. First steps are the same. Label up hypotenuse, the longest side, opposite the angle, and adjacent. Choose which one we're using. Right, we've got the hypotenuse, we've got the opposite, not using the adjacent, which means opposite and hypotenuse, that's sin. And so this is the ratio we use. Substitute in opposite 9, hypotenuse 12. There we go. Now, sine theta equals 9 over 12. We want to work out theta. To do that, we need to kind of undo sin, like the reverse, the opposite. And that is called inverse sine. And this sine minus 1, sine to the power minus 1, inverse sine, we can find that on your calculator by pressing shift sin. Nearly all calculators it will be shift or second function sin, and it's in this calculator here it's in yellow above it. So you press shift sin to do the inverse, and then you're going to put some brackets. Let's show you how you do that. Put some brackets around either 9 divided by 12 or 9 fraction 12, either one, and we should get an answer of 48.6. So the difference is that we have to press shift sign. When you're finding an angle, shift. Alright. If we're using these triangles, then the way that we do this is we cover up what we're looking for. We're looking for the angle, and then it's shift and opposite divided by hypotenuse. As you can see here, same thing. Technique there. And let's SOHCAH TOA. Remember that word. This is this doesn't work if you don't know the ratios. Okay. Final thing then. Here's 4 questions for you to try. Finding an angle. There's a mixture of sin, cos, and tan in there, and I'll give you a chance to pause the video, and then I'll do the answers in a sec. So pause the video now. Pause. Continue. Okay. Finding the angle. Let's see what we got. There's the calculations. There's your answers. Check through them, see how you did, and that's the end. If you've managed to work out those, finding an angle, finding lengths when we multiply, finding lengths when we divide, those are the 3 sort of types of question that you might get with trigonometry. Hope you learned something. Thanks for listening. Goodbye.